Hello friends, I welcome you in lecture number 32 on partial derivatives. In this lecture, we will discuss one question on partial derivatives which was asked in GTU Summer 2019 exam. First, we understand what is this question about. Suppose small f is a differentiable function of two variables x and y, and g is a function of u and v which is equal to f of e raised to u plus sin v, comma e raised to u plus cos v. Use the following table to calculate partial derivative of g with respect to u at point 0, partial derivative of g with respect to v at point 0, and partial derivatives of g with respect to u and v at point 12. And here we are given values of function f and g and values of partial derivatives of function f at point 0 and 12. So first we notice that it is given that f is a differentiable function of x and y, and g of uv equal to f of this comma this. So because f is a function of x and y, we will consider x equal to e raised to u plus sin v and y equal to e raised to u plus cos v. So f can be written as f of xy, where x equal to e raised to u sin v and y equal to e raised to u cos v. That is, f is a function of x and y and y are functions of u and v. So first we start by considering this that let small x equal to e raised to u plus sin v and y equal to e raised to u plus cos v. It is given that f is a function of x and y, and if we compare this with f of xy, we have x equal to e raised to u plus sin v and y equal to e raised to u plus cos v, and it is also given that g of uv equal to f of xy, where x equal to e raised to u plus sin v and y equal to e raised to u plus cos v. And we have to obtain partial derivatives of g with respect to u and v at points 0 and 12. So first we differentiate g partially with respect to u, that is, we find out del g by del u, and because g and f are equal, we can write this as del f by del u. Now here f is directly function of x and y are functions of u and v, therefore we will apply chain rule. F is directly function of x and y, so first we differentiate f with respect to x and with respect to y, and here we are differentiating f with respect to u, therefore in the product we have to write partial derivatives of x and y with respect to u, del y by del u, and this is by chain rule for partial derivatives. And therefore this I can rewrite as, this is another notation for partial derivative of g with respect to u. This I can rewrite as f suffix x del x by del u can be obtained from this. If we differentiate this with respect to u, we consider v as constant. So derivative of e raised to u with respect to u is e raised to u, and because v is constant, sin v is also constant, so its derivative with respect to u is 0. Similarly, del f by del y can be written as f suffix y, and del y by del u, that is derivative of e raised to u plus cos v with respect to u, is e raised to u plus 0, because we consider v as constant when we differentiate with respect to u. Now here we have to decide value of del g by del u at 0 and at point 12. So first we find out value of del g by del u at 0. Now notice that g is a function of u and v, So here we are interested in the value of del g by del u at 0 0, and because g is a function of u and v, del g by del u is also a function of u and v. Therefore we have to consider u equal to 0 and v equal to 0, and because f is a function of x and y, and x and y are functions of u and v, so here when I write del g by del u at 0 0, so at that time here also I will put u equal to 0, and I am interested in the value of del f by del x at uv equal to 0 0, but f is directly a function of x and y. So because f is a function of x and y, del f by del x is also a function of x and y, and we are considering u equal to 0 and v equal to 0. So to find out this value, first we have to decide the point xy corresponding to this point uv equal to 0. So first we find out that when uv equal to 0, what is our point xy. So uv equal to 0 implies u and v both are 0, and if we substitute values of u and v as 0 in these two equations, first I put u equal to 0, v equal to 0 here. So here I have e raised to 0 plus sine 0. So value of x is e raised to 0 plus sine 0. Sine 0 is 1, that is x equal to 1, and y is e raised to u plus cos v. U and v are 0, therefore e raised to 0 plus cos 0, and e raised to 0 plus cos 0. Cos 0 is 1, so we have 2 here. So whenever we consider, this is order pair 0 0, whenever uv equal to order pair 0 0, this xy will take these two values 1 and 2. So whenever I will find out del g by del u at 0 0, here I have to find out del f by del x at this point 1 2, because f is a function of x and y, therefore del f by del x is a function of x and y. So whenever we take uv equal to 0 0, we have to find out corresponding values of x and y. So in the next step we consider value of del g by del u at uv equal to 0 0. So here I will write del f by del x at point 1 2, this quantity. Here I will put u equal to 0. Same thing here, del f by del y at point 1 2 and into e raised to u, that is e raised to 0, and e raised to 0 is 1, and we are given in the table values of partial derivatives of f with respect to x and y at 1 and 2 are given. So we find out what is del f by del x at point 1 2. So I have to look in this row, so it is 2, and del f by del y at point 1 2 is 5. Here we substitute del f by del x at point 1 2 is 2, e raised to 0 is 1, del f by del y at point 1 2 is 5, e raised to 0 is 1, so we have 2 plus 5, that is 7. So we have obtained value of del g by del u at 0 0, and it turns out to be 7. Now we are interested in the value of del g by del u at this point 1 comma 2. So here first we find out corresponding values of x and y. We have u v equal to 1 2, so where I have to take u equal to 1 and v equal to 2, and this is our x. So if we take u equal to 1 and v equal to 2, we have e plus sine 2, and similarly y is e raised to u plus cos v. Therefore if we take u equal to 1 and v equal to 2, we have x equal to e plus sine 2, y equal to e plus cos 2. So here instead of 0 0, we will put uv equal to 1, 2. So here we will require values of partial derivatives of fx at these 2 points, at these points, fx e plus sin 2 comma e plus cos 2. Now f is unknown function of x and y, and its value at this point e plus sin 2 e plus cos 2 is not given in the table. You can see value of partial derivatives of f with respect to x and y are given at 0, 0 and 1, 2 only. So there might be some error in the question. So we ignore this part because we are not given values of del f by del x and del f by del y at this point, e plus sin 2 comma e plus cos 2, and that will be same thing for this derivative also. Here also we require values of del f by del x and del f by del y at this point, fx e plus sin 2 e plus cos 2. So we ignore these two derivatives, and we stop our lecture by calculating this value del g by del v at 0, 0. So now we write down the formula for del g by del v, and we have g of uv equal to f of xy. Therefore del g by del v is equal to del f by del v. F is directly function of x and y. Therefore first I differentiate f with respect to x and y, and because x and y are functions of u and v, and we are interested in the partial derivative with respect to v, we write down partial derivatives of x and y with respect to v in the product, and this is by chain rule. In the next step we find out del x by del v and del y by del v, and we substitute them here, and therefore partial derivative of g with respect to v equal to, I keep this del f by del x as it is, del x by del v. So I recall that x is nothing but e raised to u plus sin v, and we are differentiating with respect to v. So we consider u as constant. Therefore derivative of e raised to u is 0, and derivative of sin v is cos v, plus del f by del y and del y by del v. So value of y is e raised to u plus cos v. Therefore derivative of y with respect to v is 0, and derivative of cos v is minus sin v. So here let me rewrite this as this notation, del g by del v. Now we are interested in the value of del g by del v at point 0, 0, that is u equal to 0 and v equal to 0, and we have obtained corresponding values of x and y as 1, 2 for this point. So here we write del f by del x at point 1, 2, and u and v are 0, so here we write cos 0, and this negative sign del f by del y at point 1, 2 into sin 0. Therefore del g by del v at 0, 0 equal to value of del f by del x at point 1, 2, that we can write from the given table. Del f by del x at point 1, 2 is 2 here, so that we substitute here del f by del x at point 1, 2 is 2, cos 0 is 1, and here sin 0 is in the product, so 0 into this value, that is going to be 0, and this becomes 2. Therefore partial derivative of g with respect to v at point 0, 0 is 2. And we are also asked to find out partial derivative of g with respect to v at point 1, 2, but as we discussed that if we have values of u and v equal to 1, 2, then values of x and y are e plus sin 2 and e plus cos 2. So we will require partial derivatives of f with respect to xy at this point, but these are not given in the table, so we are not able to decide these two values, del z by del u at point 1 2 and del z by del v at point 1 2. But we can easily decide these two values simply by using chain rule. So this is nice application of chain rule, and we stop here. Thanks for watching.